Okay, so let's take a look at this MCQ. It's from 2017. The thing is, we haven't met questions with these Gibbs energy change graphs. So first of all, you must get some ideas about this Gibbs energy. So we already know that when the Gibbs energy change is negative, it's a feasible reaction. So when it is positive, it's an unspontaneous reaction. And when the delta G is equal to 0, it is at equilibrium. So if you look at that, this is a statement MCQ. So you should understand, they actually asking about the equilibrium constant in statement A. Now from our graph, we know that we can get an idea about this delta G, the change in delta G values. So if you consider that, this is going to be the reactants section and this is going to be the product section, where A gas is producing B gas according to the question. And you should understand, the reactants Gibbs energy change is around here and the products Gibbs energy change is around here. So if you just look at this, product minus reactant, since the reactant is having a higher Gibbs energy change, you will have a delta G value of negative. And when you just change the temperature, they are saying T2 is greater than T1. When you increase the temperature, you are having a different reaction pathway. And again, the logic is the same because again the reactant section is quite larger than him and it is comparatively greater than this guy. So again in here the delta G value is negative and it is quite greater than him. So you can see that out of these two reactions, the most feasible reaction or as the most spontaneous reaction is when the temperature is T2, because the delta G value is negative and it is greater than him. So it is something like -2 and -10 kilojoules per mole. So that's the first thing you should understand. And the next thing is, they are speaking about the equilibrium constant. So you should understand where is the equilibrium point in the graph. Because if you look at here, the delta G is equal to 0 section is going to be the equilibrium point. So if you look at here, now if it's unable to relate, now just take your displacement time graph in physics. The sections where the gradient is getting flat, where the delta Y value is equal to 0. That's the thing you should understand. Whenever the gradient is flat, the delta Y value will be equal to 0. Because you are having the same Y value under that case. The Y value around here and the Y value around here are the same. So that's why the gradient is equal to 0 under that section. So similar in nature, if you want to find the delta G equal to 0, you must consider where the gradient is flat. So if you look at here, there's a certain angle. So it is around this point where the gradient is flat. So you should understand that is the section of the first equilibrium point. So when the temperature is T1, the equilibrium is at this point. And you can see that when the temperature is increased, the new equilibrium point is somewhere around here because it is getting flat around this section. So the equilibrium point is going to be around here. So you can see that when you are changing the temperature, the equilibrium constant is getting changed. Now the next equilibrium is present around here. That's the key point which you should understand. Now in the statement A, they are asking us whether the equilibrium constant is increasing or decreasing. To understand this, let's get an idea. You know, equilibrium constant is concentration of products with the state and stoichiometry divided by concentration of reactants. So the thing you should understand is, when the product's concentration is greater, that means concentration of products over concentration of reactant. I didn't consider any powers or anything. You should understand when the concentration of the product is increasing, our equilibrium constant is starting to rise up, right? That's the logic you should understand. Now, as I said, in the pathway 2, where the temperature T2, it is more spontaneous to produce B. So you should understand, even the equilibrium point has shifted more towards the product. It was around here, then it has moved more towards the product. Which means the equilibrium constant has increased. The equilibrium constant is increasing. The reason is, you can just look at from the graph, since it is moving more towards the product. That's the first thing. So if more products are getting formed, its equilibrium constant is increasing. That's the logic you should understand. Now if you look at statement B, now you can get these sort of questions. That means without even having a graph, you can just get an idea about the equilibrium constant. Now it is actually A gas producing B gas. Let me erase it. A gas producing B gas. So the thing you should understand is, when I'm increasing the temperature, more B is getting produced. Which means the forward reaction is favored in this case. So the thing you should understand is, because the temperature is increasing, high temperature to low temperature system will start to favor. Since more B is getting produced, this has to be the low temperature and this has to be the high temperature regions. And to become a high temperature region, there has to be an extra energy present to him. That is the energy present due to that enthalpy. So when it is present in the reactant side, it is an endothermic reaction. If it is present in the product side, it is an exothermic reaction. So from this point, we can verify it. It is an endothermic reaction. It's an endothermic reaction. So these are the things you should understand. So without a graph also, we can have a question. They might say, this is a situation where A gas is in equilibrium with B gas. The forward reaction is an endothermic reaction. If the temperature is increased, what will happen to the equilibrium constant? So just remember, if it is an endothermic reaction, when you increase the temperature, if it is an endothermic reaction and when you increase the temperature, my equilibrium constant will anyways increase. So these are the short points which you should get from here. When it's an endothermic reaction and when you increase the temperature, the equilibrium constant is going to increase. So anyways, A and B is correct. So answer number D is wrong because they are saying it's an exothermic reaction. Let's now look at it. Answer number C. So they are saying us the entropy is a positive value. Now in here, you are having A gas and B gas. Both the section there's gas. So whenever more gas is getting produced, it's a positive entropy. But anyways, let's verify it. You can see the equation is delta G delta H minus T delta S. So the thing you should understand is, in both the reactions, the delta G is negative. You are having a negative value. And it's an endothermic reaction, so enthalpy is positive. Minus T delta S. You are having a positive value and a negative value. Now if I just send this positive to the other side, I'll be having a negative value. So a negative value plus another negative value is equal to minus T delta S. So anyways, when you add two negative values, you will be again having another negative value. So the thing you should understand is, you are having a negative value minus T delta S. So negative will become positive then. Because when you divide it by minus T, my entropy change will be a positive value. My entropy change will eventually be a positive value. So these are the things you should understand. When it's an endothermic reaction, when you increase the temperature, equilibrium constant increases. And to verify whether it's whether entropy is positive or negative, we can anyways use the equation. Or else the clue is when more gases are getting produced, its entropy is positive. And from whenever there's a Gibbs energy graph given, just remember, if the Gibbs energy change is negative, it's more feasible or else a more spontaneous reaction. The point where the delta G is equal to 0, the flat lines, represent the equilibrium point. Okay, so I hope you're okay with this, and yeah, do check on our website. I think I have uploaded this.